This is the tutorial of the MATLAB code for Dr. Kota's course ENGI 1331, Reducing Stress on City Infrastructure. I am Assad Soomro, and my partners Rene and Efosa have coded a solution to reduce stress on today's infrastructure. Today's infrastructure is under a great amount of stress. As a group, we thought that a quick and economical fix would be to reduce stress on the current infrastructure such as highways and roads. Through our MATLAB code, we wanted to optimize the city's resources and provide the user with an alternative mode of transportation as well as a statistic such as the average commute time in the city and the population of the city. The main purpose of our code is to give the user an alternative method that would optimize the city's resources such as the local metro and other public transportation, such as the rural line, as well as reducing the stress on the city's infrastructures. For our data, we have composed all our data into 4 sheets into one Excel file. Throughout the sheets, the corresponding data, right here, they're all For our data, we have composed all our data into one Excel file with 4 sheets. Throughout the sheets, the corresponding data, such as the city's commute time, population, and transportation methods, are all corresponding by the same row number so it can be conveniently extracted. In our first sheet, we have cities in the following states. Second sheet, we have commute times in minutes, population, as well as the first main transportation method that will be used, and an alternative method. To start this code, we have imported the data from the Excel file that I have showed you, and it is entered as a structure. So that means that it takes the text and puts it in one, and it takes all the numbers, all the values, and puts it into another. So text data contains cities and transportations, which contain the strings of the cities and states. And the methods of transportations, they're all strings. And then x.data contains the numbers, such as the values right here, the cells, and x.data.population contains the population numbers. To continue, we started with a while loop in order to ask the user the inside this while loop, again question equals 1, we ask the user to enter a state, then that would be compared to the column of states in our Excel file that we had imported. And if the state was not in our system, MATLAB would skip to line 159 and then produce a warning saying that it was not in our system. And then we added a continue function in order to skip the following lines of code and repeat the while loop. So when the while loop repeats, we ask the user to enter a state and say that the user entered the right state. Then it would make sure, and then it would extract the row number in the columns in order to extract the following states, cities, population, times, and transportations of the chosen state, sorry. And then we would ask the user to specify a city by creating a menu that would have a list of cities that we had extracted for that state. If the user accidentally or chose to exit the menu, we give a error and tell them that their program has been terminated. So for the following cities, we would after they choose the city, we extract the actual current city, the chosen state, the chosen population, the chosen commute time, and transportations. Then we would output the chosen city with its following population, the average commute time for that city, and the most used transportation method. So then we would actually uh, suggest an alternative in order for them to reduce the stress and hopefully improve their commute time. In order to do that, we chose their second mode of transportation that we imported. We were able to string compare it to a predefined uh, string, and depending on that string, we have created a explanation for that string. So if we go back to the if statement, if mode 1 is right here, if second mode that we have found for that chosen city is comparable to mode 1, which is predefined, driving alone, it would be able to, one second, it would be able to produce an explanation for that following. And therefore, if it wasn't, then it would go to the second mode, and therefore it would go to the third mode. And that would be that for that if statement. After we have extracted and outputted the data for the first city, we would ask the user in a menu to either run the program with a different state, compare the previous city to another city, or end the program. Based off that menu selection, if they chose to run the program with a different state, we would actually tell the MATLAB code to restart from the beginning and start the while loop again and ask this for a new state. If the user wanted to compare the previous city to another city, then we would start we would start this if statement, which asks the user to specify a second city, and if they chose to exit that menu, then they would actually be the code would be terminated. But if they chose a city from a list of cities from that state, from the previous city and state, we would extract the second chosen city data for the state, population, commute time, transportation, and this mode. We would compare the mode again and find the correct explanation, and we would store it into explanation 2. Then we would actually create a comparison table, and in the beginning we would want to calculate the difference in population for statistics. So I did the population difference, and then if it was less than 0, it would be the first city. Not the first city, the second city would be greater. So that would be the string of that city would be equal to pop city, or else pop city would be equal to the first chosen population right here. And then the actual difference, the population difference, we would have to take the absolute value just to make sure that was positive and it was ready to be outputted. For the commute time difference, we did basically the same thing. We took the chosen city 2 commute time, subtracted from the first commute time. If it was less than 0, that meant this one was bigger, the first city, and we would make commute city equal to the first city, or else the commute city would be equal to the second city. And then we would take the absolute value just to make sure it was positive and ready to be outputted. Then we would actually output the statement, and we would do the pop city pop diff, which is the population city and population difference, the commute city and the commute time difference. We would output the transportation method. So for the transportation method, there's basically 2 options. A second mode, there's if the methods of transportation are the same, then it would be both of the cities are proposed too, and that would be the method for that city, for both cities. And the second option would be two different state modes, and they would both be outputted with their actual transportation and their following explanation. Now that I have explained the code, we will run through a couple of scenarios that the code could go through. We will hit run, go to the command window, and it asks you to enter a state. So we will enter Texas. So unless cities pop up, we will hit Fort Worth. So when we hit Fort Worth, we actually check if it's in the state column in the imported data, and if it is, then therefore it outputs all this data. So we will hit, let's say, run program. So you get three options: run the program with a different state, compare the previous city to another, or end the program. We will run with a different state. We'll say California. List of cities pop up. We will, let's say, do Los Angeles. Then the data pops up. Let's say we do a different state, but say we want to do New Mexico. We get a warning saying that the state is not in our system, and it would ask the user again to enter a state that they would like to analyze. Say we do New York. We get one city, which we will hopefully expand, and then we get our data again. So now that we have done that, we will choose to end the program, and the user in the MATLAB code has actually ended, and therefore we will go through our second scenario. For the second scenario, this is where we could compare two cities. So, for example, we will do Texas, and let's say we'll do El Paso, and then we'll compare with Austin. So, this is the outcome where we have the same method of transportation, and we'll have the difference of commute time, difference of population, and just a couple statistics. For the third scenario, we will run it again, and we will analyze California, and we'll pick Los Angeles, compare the previous city to another, Los Angeles to San Jose. This is where there's two different methods of transportation. So we have the difference of population, difference of commute time. We have the recommended transportation for Los Angeles and its alternative. And then San Jose is recommended to carpooling. And we have the explanation for why it will be helpful for the city, and it will reduce the strain on infrastructure. For the fourth scenario, for the last scenario, I'll be showing you how a menu will be exited and how the code will will respond. So we will type in Florida to be analyzed. We will hit Tampa. Then let's say we want to run the program with a different state. Choose Washington. And instead of choosing a city, we exit the menu. You exit out the menu, an error pops up. You did not specify a city. Program terminated. And this is our last scenario. Things that can be added and improved can be estimate the amount of time the whole city commutes, the amount of money saved from the decreasing amount of maintenance and repairs. This will help actually provide data for statistics for that to decrease the stress on infrastructure. In the future, we could implement a entry where they can store data into a new data structure, and that's pretty much it. Thank you. In conclusion, through this code, we have tried to reduce the stress on infrastructure and optimize the city's resources by suggesting alternative modes of transportation. Thank you for watching.